Alright, let's look at the solids of revolution. Alright, I'm going to introduce a couple of methods to find the volume of solid of revolution. And the first one is a disk method, and the second one is a washer method. Alright, so let's look at the disk method. Alright, let's say you have a region under the curve, the graph of f of x from A to B. I'm going to rotate the region about the x-axis. Alright, so the solid that you're going to get is going to look somewhat like this. Alright, so it looks like that, and maybe you can't see that side, and it goes somewhat like that. Alright, so you have this solid, and what we want to do is we want to find the volume of this solid. Alright, so all you really have to do is figure out how to express the cross-sectional area. Alright, so let's slice it perpendicular to the x-axis. So cross-section is going to be actually a circle. It's going to be circular. So if you cut it through here, and it's going to look somewhat like that. Since this is a solid of a solid of revolution, the cross section is going to be a circle. So let's say this is going to be x. Alright, so the area A, maybe I'll use a different color here. Alright, so cross-sectional area A of x is going to be, since it's a circular, it's going to be pi radius square. Right, so it's a pi, and the radius is going to be determined by this function f. So that's going to be our radius r. So r is going to be function f of x and squared. Right, once you know the expression for the cross-sectional area, all you have to do to find the volume would be integrated. So you have a volume is going to be integral from A to B, and the pi is just a number, so I'll just put it outside. Then you have f of x squared dx. Alright, so since we're using the approximating disk, it is called the disk method. Alright, so the slight generalization of disk method is a washer method. What if you have two curves and to bound the region, and we're going to rotate about the x-axis again? Then as you can see, you're going to have a solid just like the one we had before, except that there's going to be a hole in the middle. Right, so it's going to look kind of like that, and the curve is going to be like that, but there's going to be a hole in the middle, so the hole is going to look probably something like that. Right, so if you cut it perpendicular to the x-axis, cross-section is going to be it's going to look like a washer. So you have an outer circle here, and there's going to be a hole in there. So there's going to be a hole right here. Right, so in order to express the area, so the area is going to be a washer shape here. So we're looking at the donut here. Right, so we're interested in finding the area of that. So a of x is equal to, alright, so look at the disk area of the circle is going to be pi. Alright, outer one would be f of x squared. Then we have to subtract the area of the inner circle, so it's going to be pi, and that's determined by g of x squared. Alright, and we can pull out the pi since both of them have a pi in there. So it's going to be f of x squared minus g of x squared. Alright, so if you want to find the volume, v is going to be equal to integral from a to b. we can leave pi outside. Then you have f of x squared minus g of x squared dx. All right. This is called the washer method because we're using the approximating washer. All right. That's it. I hope that this was clear.